Assistant Professor in Andhra Pradesh State University's Electronics and Communication Engineering 2018 Question Paper Solutions Part 4, that is from question number 91 to question number 120. Question number 91. If the voltage gain of transistor amplifier is 200, supply voltage is 15 volts and the input AC signal is 0.1 volt, then the output voltage is. So in the question, given input AC signal voltage is 0.1 volt, gain of amplifier is 200, bias voltage VCC is 15 volts, bias voltage VCC is 15 volts. So in an amplifier, we know that input voltage multiplied with gain will result in output voltage V0. So output voltage is gain into input voltage. Given gain of amplifier is 200, input voltage is 0.1 volts. Therefore, output voltage is 20 volts. But this 20 volts option is incorrect because in a transistor, the output voltage amplitude never exceeds bias or supply voltage due to the onset of linearity. So due to the onset of linearity, the transistor output voltage amplitude never exceeds bias or supply voltage. Therefore, output voltage is biasing voltage VCC, which is 15 volts. So correct answer is option 3. Question number 92. The Q point of transistor is chosen. So generally, the Q point of transistor might be in cutoff region, might be in active region, or it will be in saturation region. If Q point of transistor is in cutoff region, then it is said to be, the transistor is said to be off. If the Q point of transistor is in saturation region, the transistor is said to be in on state. If the Q point of transistor is in active region, then the transistor is said to be acts like an amplifier. If the Q point is midway between cutoff and saturation regions, the output characteristics of the output characteristics of transistor on a load line, then faithful amplification is possible. This faithful amplification is a process of obtaining complete portions of input signal by increasing the signal strength. In this image, Q point of the transistor is exactly at the middle. Input waveform shape and output waveform shapes are similar and amplification is done. If the Q point is close to saturation region, in this case, a portion of output signal is clipped. Signal excursions will take place. Similarly, if Q point is close to cutoff region, then a portion of positive cycle is removed here. So, therefore, signal excursions in cutoff and saturation region should be avoided. That's why Q point should be exactly at the middle of load line on the output characteristics. Correct answer is option 3. Q point of transistor is chosen midway between the cutoff and saturation of output characteristics of transistor on a load line. Question number 93. Which of the following devices given below have negative resistance? So, BJT, MOSFET, UJT and FET. So among these options, unijunction transistor, UJT have negative resistance. It exhibits negative resistance, and the other devices are tunnel diode and gun diode that exhibits negative resistance. Let us see the characteristics of UJT. And this is a region in between. It is a region in between. It exhibits negative resistance. That is, as current increases, voltage is decreasing. Negative resistance region. Correct answer is option 3. Question number 94. Given two binary numbers x and y, Perform the subtraction using 2's complement. So the given binary numbers are x and y represent. So in the question they have asked y minus x represent minus x in 2's complement form. So this is x given here. So x in 1's complement form is replace 0 with 1 and 1 with 0. So that is 0 1 0 1 0 double 1. So that is 1's complement of given x. 2's complement is adding plus 1 to the 1's complement will result 2's complement. So 1 1 in binary addition is 0. For 1 it is, so carry will be generated. So carry will be 1. Again 1 1 it is 0, carry will be 1. So 0 plus 1 is 1. So and finally we will get 0 1 0 1 1 0 0. This is the 2's complement of minus x. Now y minus x, that is y plus minus x can be written as plus 2's complement of minus x. Y is 1 0 0 0 0 double 1. 2's complement of minus x is 0 1 0 double 1 double 0. Now let us do the binary addition. 1 0 is 1, again 1 plus 0 is 1, 1 plus 0 1, 1 plus 0 1, 0 0 0, 1 plus 0 1, 1 plus 0 1. Here carry is not generated in the MSB position. So if carry is not generated in 2's complement form, the result is negative and it is in 2's complement form. So result is negative and 2's complement of double 1 0 double 1 double 1. So for this 2's complement is, initially find the 1's complement. Replace 1 with 0 and 0 with 1. Double 0 1 double 0 double 1 and add plus 1, that is double 0 1 double 0 0 1. The result is negative. The result is negative and is in 2's complement of the result. So correct answer is 0 0 1 0 0 0 1. The result is negative 0 0 1 0 0 1. This is the answer. Option 1 is the correct answer. Next, question number 95. Using the following Boolean expression, find out the sum of minterms and minimal sum of products expression. So given expression f is equal to a bar c, a bar b, a b bar and bc. So convert this sum of products form or disjunctive normal form into a standard sum of products form or minterm canonical form. So for that we need to add the missing literal. So in this a bar c, b is missing. So multiply with b plus b bar. So b plus b bar is 1. Variable plus complement of variable results in 1. Similarly, in the second term, a bar b, c is missing, multiply with c plus c bar. So third term, all the three variables exist. In fourth term, bc variable a is missing, therefore multiply with a bar. And then discard the repeated terms, we will get the final expression f of abc is equal to sigma m of minterm 1, minterm 2, m3, m5 and m7. So using this, for this function, apply k-map. Using k-map, so we will get the resultant expression f is equal to c plus a bar b. Here the resultant expression f is equal to c plus a bar b and minterms are 1 2 3 5 7. So correct option is 1. Question number 96. How many gates are used in full adder? So in the question they did not mention which type of gates, either universal gates or basic and or not gates. This question is deleted from the question paper. Anyways, we will see the solution for this. To implement full adder, To implement full adder, 9 two inputs NAND gates are required, or 9 two inputs NOR gates are required. Similarly, to realize a half adder circuit, 5 two input NAND gates, 5 two input NOR gates are required. To realize full adder full adder circuit using basic gates and or not, number of gates required is 6. Similarly, to realize half subtractor, number of two input NAND gates required is 5, NOR gates required is 5, but basic gates required is 6. Basic gates required is 6 here. To realize full subtractor, number of two inputs NAND gates required. NAND gates required is 9 and NOR gates required is also 9. In the question, they did not mention which types of gates are used, hence this question is deleted. To implement full adder or full subtractor using universal gates, number of gates required is 9. Question number 97. The decoder represented as n by m line decoder where we need to find the relation between input and output. Here n represents number of input lines and m represents number of output lines. We know that decoder is a combination logic circuit. Decoder is a combination logic circuit which has multiple inputs, multiple outputs that converts coded inputs to coded outputs where input and output codes are different. Here n input decoder produces 2 power n possible output codes. So here n input decoder produces m output lines and the number of m output lines are 2 power n. In m by m decoder, generally the number of output lines are, so ideal case, if all outputs are used, if there is no don't care condition, n input produces 2 power n outputs. If don't care conditions exist, then n input decoder produces less than 2 power n outputs. So the correct answer is n less than or equal to 2 power m. M less than or equal to 2 power n. Here m is output is 2 power n or less than 2 power n. If all outputs are used, m is equal to 2 power n. If there is a don't care condition exists in the decoder, then m less than 2 power n. All the output lines are not used. So correct answer is m less than 2 power n, option C. 3. Question number 98. In Mealy model of finite state duration, the output is a function of. So state machine is a mathematical tool of computation used to design a sequential logic circuit. These state machines are of two types. One is Mealy machine and then Moore machine. So Mealy machine and Moore machine. So in Mealy machine, the output depends only on present input and present state, whereas in case of Moore machine, output depends on present state only. It is not depending on input. Therefore, correct answer is option 1. In Mealy machine, output depends on both present state and present input. Output depends on present state and present input. In case of Moore machine, output depends only on present states. Question number 99. The characteristics of T flip-flop is. So T flip-flop or toggle flip-flop is a modification of JK flip-flop. T flip-flop is obtained from JK flip-flop by connecting both the inputs J and K together. So that is, take a JK flip-flop, J, K, output Q. So here J input and K inputs are connected together with a single line, then it is T flip-flop. Then it acts like a T flip-flop. That is T input, Q output. The truth table of T flip flop is if T is 0, Qn plus 1 is Qn. If T is 1, Qn plus 1 is Qn bar. It results in Qn plus 1 is equal to T plus Qn. The characteristic equation is T XOR of Qn, that is T Qn bar plus T bar Qn. Similarly, the characteristic let us see the characteristic equations for other flip flops. For SR flip flop, Qn plus 1 characteristic equation is S plus R bar Qn. For D flip flop, delay flip flop, Qn plus 1 is D input. For JK flip flop, J Qn bar plus K bar Qn. So T flip flop, J is equal to K, that is T Qn bar plus T bar Qn. It is written as T XOR of Qn. That is a characteristic equation of, these are the characteristic equations for different flip flops. According to the T flip flop, characteristic equation is T Q bar T bar Q. Question number 100. It is related to the latches and flip flops. So latches and flip flops are bistable elements under the basic building blocks of most of the sequential circuits. For a flip flop, change in output will take place. Change in output for a given input depends on clocking signal. For a latch, change in output for given input is independent of clock signal. So these latches are level sensitive, either positive level sensitive and negative level sensitive. And flip flops are pulse or edge triggered, positive and negative pulse triggered, positive edge and negative edge triggered. Therefore, according to the question, latches are level sensitive and flip flops are edge sensitive devices respectively. Correct answer is option 3. Next, question number 101. Which of the following acts like a transparent delay? That is D latch. D latch or D flip flop is a flip flop with delay element where delay is exactly equal to one cycle of clock. D flip flops are also called data transmission flip flops. The Q output follows the D input. Here in D flip flop, Q output follows D input. This is a logic symbol of D flip flop. So D latch is also called transparent latch or gated latch, transparent latch, gated latch or data latch. It can also be referred as delay flip flop, transparent, gated, data, delay flip flop. These are the different names for the D latch or D flip flop. Question number 102. Digital TV is a practical application of dash flash memory. So digital TVs use flash memory to store firmware, user settings and sometimes even media content. So firmware is a type of BIOS and user settings. So these are stored in the flash memory of digital memory. So in digital TVs doesn't use ROM, read only memory. So it doesn't use RAM because it is a temporary memory. It is also not using EPROM, where EPROM requires special equipment to erase the data. Unlike flash memory, EPROM is not flexible and widely used. These are not the correct options. Correct answer is flash memory. Question number 103. So this question is deleted. Let us see. ECL offers. ECL means emitter coupled logic. The other name for ECL is current mode logic or current steering logic. Current mode logic or current steering logic. ECL family characteristics of ECL family are: it is a non-saturated logic family. ECL is a non-saturated logic family. Transistors never go into saturation. It is the fastest of all logic families, hence used in super computers. ECL consumes more power, highest power consumption. Fastest of all logic families, highest power consumption. ECL provides wired OR logic. ECL uses negative logic levels. ECL provides complementary outputs. Basic gate in ECL logic family is OR gate or NOR gate. ECL is very costly and it suffers from the problem of cooling. These are the characteristics of ECL. Fastest logic family. The other name for ECL is current mode logic or current steering logic. The transistors in ECL emitter coupled logic family never go into saturation. It consumes more power, that is highest power dissipation. ECL provides wired OR logic, and it also provides complementary outputs. Basic gate in ECL is OR gate or NOR gate, and it suffers the problem of cooling. Now, the given options are low propagation and high speed. It is not propagation, it is only high speed. Low propagation delay, least propagation delay. So options are not correctly mentioned, hence the question is deleted. So we can take option 4 as correct answer. High power consumption. It is not consuming the power, it is dissipating the power. High power dissipation. Question number 104. Simplify the Boolean function f w x y z. Variables in the function are w x y z is equal to sigma 1, 3, 7, 11 and 15, and don't care conditions are 0, 2, 5. So using k map, this is a given Boolean function. Using k map, arrange the minterms in the k map. Then we will get 4 ones are there. This is forming a quad. For these 4 ones, the equivalent expression is yz. Quad eliminates 2 variables. In k map, we know that quad eliminates 2 variables. Octet, it eliminates 3 variables, and then a group of 2 eliminates 1 variable. Quad is group of 4, octet is group of 8. So here it will, all the 4 ones in vertical line will form a quad. So it eliminates 2 variables and the resultant expression is yz. Similarly, instead of taking 2 elements, 2 groups here, 2 ones group here, we will treat this by don't care condition value as 1, so that it will result in octet. Again, it will result in quad. The quad eliminates 2 variables. So that is, we need to keep this don't care condition 1 and this don't care condition value as 0 and 0. So from this, we will get function f, resultant function f is equal to w bar z plus yz. Take z as common. The function f is equal to z into w bar plus y. Correct answer is option 3, z into w dash plus y. Question number 105. In general, ROM, read only memory, contains decoder k and OR gates n. What is the relationship between k and n? So this PROM, programmable read only memory, it is a device that includes both decoder and OR gates, within a single IC chip. PROM is a device that includes both decoder and the OR gates with a single IC chip. It consists of n input lines. and m output lines. Each bit combination of input variables is called address. There are n input lines and each bit combination will give address. Each bit combination that comes out of the output lines is word. So here bit combinations will result word. Here bit combinations will result address. There are 2 power n distinct addresses, 2 power n different addresses in the PROM, that is 2 power n different words. The number of bits per word is equal to number of output lines. The word available on the output lines at any given time depends on the address value applied to the input lines. So this is a theory related to PROM. Now the relation between k and n here is 2 power k into n. There are k input lines, 2 power k addresses, and each address will result in n bit output word. 2 power k addresses, that is total number of memory locations is 2 power k, n number of bits stored in each memory location, that is width of the data output word. The total number of locations and bits per locations is 2 power k into n. Correct answer is option 4. Question number 106. PLA, programmable logic array, that is programmable AND gates, programmable OR gates. In case of PAL, programmable AND gates, fixed OR gates. In case of PAL, programmable AND gates, fixed OR gates. In case of PROM, fixed AND gates, programmable OR gates. Correct answer is option 3. PLA, programmable logic array, have both AND gates and OR gates programmable. Question number 107. Using tens complement, subtract 72532 and 3250. The 9 complement of 03250, that is 3250. So keep 0, it doesn't change, its on MSB side its value is not changing. We need to find the 9's complement similar to 1's complement. So 0 is taken as 9. So taking 9's complement is subtract each digit from 9. 9 minus 5 is 4. 9 minus 2 is 7. 9 minus 3 is 6. 9 minus 0 is 9. 9, 6, 7, 4, 9. To find the 10's complement, add plus 1. 9 plus 1 is 10. 4 plus 1 is 5. 7, 9, 6, 7, 5, 0. So this is 10's complement. So now 73252 minus 03250. So it can be taken as 73532 plus 10's complement of this 3250. 10's complement is 96750. And then after addition it results 169282. So here carry is generated. Carry 1 is generated. In 10's complement, if carry is generated, discard the carry and the remaining digits are the required results. If carry is not generated here, then result is negative and is in 10's complement form. If carry is generated, discard the carry and remaining digits are the result. So the correct answer is 69282. Option 3 is the correct. Next question. Write the odd parity of ASCII code 1010100. So we know that odd parity, the total number of ones in given binary string are odd. For even parity, the total number of ones in given binary string are even. So given ASCII code is 1010100. The total number of ones in the given binary string are 3. Therefore, add 0 to the left of MSB. Add 0 to the left of MSB. 01010100. Correct answer is option 3. Question number 109. Convert hexadecimal number 64CD to octal number. To convert hexadecimal to octal, there are two methods. One is hexadecimal to decimal and decimal to octal, or hexadecimal to binary and then binary to octal, or hexadecimal to binary, binary to decimal, decimal to octal. So this method is a most convenient and easy technique. Hexadecimal to binary and binary to octal directly. So to convert hexadecimal to binary number, each hexadecimal will result in 4-bit binary. To convert binary to octal, we need to group 3 bits. So that is each hexadecimal will result in 4-bit binary. For 6, binary is 0110, for 4, 0100, for C, 1100, for D, equivalent binary is 1101. This is how we convert hexadecimal to binary. And then make a grouping of 3 digits to convert the binary to octal. That is 110, 010, 011, 001, 101. So we have make a grouping of 3 digits 101, 001, 011 like this. Write the equivalent decimal number. That is 110 is 6, 010 is 2, it is 2, 011 3, 001 1, 101 is 5, 5 into 8. That is 5 radix is 8 here. That is 64 CD hexadecimal is equivalent to 62315. 62315 base 8. Correct answer is option 1. Question number 110. What is the clock frequency if asynchronous counter having a period of the waveform 24 microseconds and 8 clock cycles? Given time period is 24 microseconds. The number of clock cycles in T time duration is 8 clock cycles. Then time period for 1 clock cycle is, for 8 clock cycles, time period is 24 microsecond. We need to find the time period for 1 clock cycle. For 1 clock cycle, that is total time period 24 microsecond by number of clock cycles 8. Therefore, time period for 1 clock cycle is 3 microsecond. 3 microsecond. Then clock frequency is 1 by clock cycle time period 1 by 3 micro, that is 10 power minus 6. It results in the frequency of 333.33 kilohertz. Correct answer is 333 kilohertz. Question number 111. Given 8-bit analog to digital converter driven by 500 kilohertz clock, find the average conversion and maximum conversion rate. In this question, they have mentioned A to D converter, but they did not mention what is the exact A to D converter, because the number of clock cycles for conversion in flash comparator type, analog to digital converter, successive approximation type digital to analog converter, and dual slope analog to digital converter are different. So they did not mention which type of A to D converter, hence this question is deleted from the question paper. Let us try to solve this question by assuming counter type A to D analog to digital converter. Assume the question the converter is counter type analog to digital converter. For counter type A to D converter, the number of clock cycles required to convert is 2 power n minus 1 clock cycles. In the question they have given n is equal to 8, n is 8, and the number of clock cycles required in counter type A to D converter are 2 power 8 minus 1. 2 power 8 minus 1 is 255. Clocks are required to convert an analog signal to digital signal. Also given in the question, clock frequency is 500 kilohertz. So we know that time period is equal to 1 by frequency. Now time period of clock is equal to 1 by frequency. So 1 by 500 kilohertz, 2 microsecond. Clock time duration is 2 microsecond. Next to find, we need to calculate the average conversion time. Average conversion time is 255 by 2. Total clock cycles are 255. Average is by 2. And time period of each clock is 2 microsecond. Time period of each clock is 2 microsecond. That is 255 by 2 into 2 microsecond. It will result in 255 microseconds. That is 0.255 millisecond, or approximately we can write as 0.256 milliseconds. Next, also mentioned maximum conversion rate. We know that maximum conversion rate is 1 by maximum conversion time. So maximum conversion time for counter type A to D converter is 2 power n minus 1 into clock, 2 power n minus 1 into t clock. That is 2 power 8 minus 1 into t clock. Time period of each clock signal is 2 microsecond. 1 by 510 into 10 power minus 6. That is maximum conversion rate is 1960.78 conversions per second. As per the options, it is approximately equal to 1953. So approximately equal to 1953 conversions per second. So in the question, they did not mention which type of converter it is. For each converter, different conversion rates are different. Hence, this question is deleted from the question paper. Option 2 is the answer if we assume this given A to D converter is counter type A to D converter. Next question. Question number 112. What is the resolution of 9-bit digital to analog converter in percentage if full scale output voltage is given that full scale output voltage VFS is 5 volts and the number of bits here is 9 bit analog to digital converter. Resolution is, the formula for resolution is VFS full scale output voltage by 2 power n minus 1. So full scale output voltage is 5 volts, 2 power 9, that is 2 power 9 minus 2 power n is 2 power 9 minus 1. 5 by 512 minus 1, that is 511. It is 9.784 10 power minus 3, approximately equal to 10 millivolts. Resolution is 10 millivolts and percentage resolution is 1 by 2 power n minus 1 into 100, that is 1 by 2 power 9 minus 1 into 100, 100 by 511, it results 0.1956%, approximately equal to 0.195 is 0.2%. Percentage resolution is 0.2% and resolution is 10 millivolts. So that is option 1 is correct. Next question. Question number 113. What are the two important tests for checking the operation of digital to analog converter? What are the tests required for checking the operation of digital to analog converter? So that is steady state accuracy state test and monotonicity test. So this monotonic of digital to analog converter is if its output value increases, then binary inputs are incremented from one value to the next value. That is, if input increases, output also has to be increased proportionately. That is monotonicity. Next is steady state accuracy test. It checks the output of specified digital input code. And monotonicity test ensures the output voltage increases consistently as the digital input increases. And these are the two tests used to check the operation of digital to analog converter. Question number 114. For 8085 microprocessor, program is given related to 8085 microprocessor. Before that, let us see what is MVI instruction and then DCR, JNZ, ADI and HALT. So in 8085 microprocessor, JNZ, if the zero flag in previous operation resulted in a non-zero value, the program control jumps to a specified address. Otherwise, if zero flag is 0, execution continues to the next instruction in the sequence. Program flow continues sequentially. This jump not 0 is a 3-byte instruction. Next, DCR stands for decrement register. ADD adds the content of register or memory location to the accumulator and stores the result in the accumulator. ADI, add immediate, adds the 8-bit immediate value to the accumulator register and the result is stored back in the accumulator. HLT is a mnemonic that halts the microprocessor and it is an 1-byte instruction. Now initially they have mentioned MVI. Move immediate. A is equal to 0.5 and B is 0.5. A is 0.5, B is 0. A is 05, B is 5, 05 hexadecimal. Okay. Next, add B. So here B value is 5. Loop is executed. This loop is executed. Iteration 1, add B. So that is for A, add B. So that is 5 plus 5. So 5 plus 5 is 0A hexadecimal. 5 plus 5 is 10. It is 0 in hexadecimal. Next is decrement B. Now initially B is 5. Now it is decremented to 4. 5 minus 4. Again add B. For initially the accumulator previously the accumulator content is 0A. Add 4. That is 0E. For second iteration, decrement B. 0E plus 3 is 1 1 hexadecimal. Again decrement B. Add plus 2. 1 1 plus 2 1 3. Decrement B, that is B value is 1. Add 13 plus 1, that is 14 hexadecimal. Now decrement B. In this decrement, B becomes 0. Now loop is terminated. Once loop is terminated, next instruction is executed. That is add 03H. Add immediate 03H. So previously the accumulator contains 14. Now 03 is added, that is 17. Halt the program. The correct answer is 17 hexadecimal. Next question. The following sequence of instructions are executed by 8085 microprocessor. These are the instructions are given. 1000 LXI SP 27FF 1003 call 1006 1006 POP pop operation H register. The content of stack pointer and HL register pair on the completion of execution of these instructions are. After executing these three instructions, what are the contents in stack pointer and what are the contents in HL register pair? Okay. Let us see first instruction 1000 LXI. This LXI stands for load immediate 16-bit data into the register pair. So pop instruction retrieves the data from the stack and loads to a specified register pair. It is essentially reverse of push instruction which stores the data. Pop instruction retrieves the data. Push instruction stores the data back onto the top of stack. Next, whenever the instructions in subroutine are required to be executed, branch control program to the subroutine using call instruction, which is a 3-byte instruction with 2-byte opcode and 1-byte opcode and 2 bytes for address of subroutine. Call mnemonic stands for call a subroutine. After executing the instructions written in the subroutine, to return control to the next instructions, this is related to call. Okay. So step 1, first mnemonic is 1000 LXI SP 27FF. This instructions loads the stack pointer with the address 27FF. Next is 1003 call 1006. This is a subroutine call to the address 1006. 8085 call instruction. It jumps to the address 1006. Here stack point is decremented by 1. Since stack point is initialized at 27FF, it will decrement the stack pointer by 1 and store high byte of return address, that is 10. Again decremented stack pointer by 1, it stores low byte, that is 06. Initially high byte is 10, lower byte is 06. Now the contents of stack pointer are 27FE contains 27FF, decrement by 1, 27FE. 27FE contains higher order byte 10, and then 27FD, it contains lower order byte 06. Execution jumps to 1006. In 1006, pop instruction is there. So lower order byte is 06, higher order byte is 10. Now HL register pair contains 1006. And the stack pointer is incremented to 2, and again the stack pointer will reach us to 27FF hexadecimal. Here the contents of stack pointer are 27FF and HL register pair contains 1006. Correct answer is option 3. Next question. In 8085 microprocessor, instruction compare. So compare This instruction compares the two operands by subtracting the source from the destination. And while the contents of accumulator is less than B, what is the status of carry and flag register? If contents of accumulator is less than B register, then carry flag will be set and zero flag is reset. Carry flag will be set and zero flag is reset. So correct answer is option 1. The number of hardware, next question, the number of hardware interrupts present in 8085 microprocessor are hardware interrupts which require external signal to interrupt. So there are 5 hardware interrupts: trap, RST 7.5, RST 6.5, RST 5.5 and INTR, and 8 software interrupts from RST 0 to RST 7. So among these hardware interrupts, trap is having highest priority. So correct option is option 3. The number of hardware interrupts are 5. The number of hardware interrupts are 5. Next, question number 118. See here, transfer function is given. G of s is equal to C of s by R of s, s square minus 14s plus 4 by s cube plus 13s square minus 17s plus 5. Multiply this C of s into denominator and R of s into the C of s into denominator, R of s into the numerator. Upon multiplication, we will get the equation like this. Apply inverse Laplace transform on both sides. So applying inverse Laplace transform, we know that Laplace transform of d power n by dt power n x of t is s power n into x of n, and inverse Laplace transform of s power n x of s will result d power n by dt power n into d power n by dt power n into x of t. That is inverse Laplace transform. Okay. So using this, s cube can be represented as d cube by dt cube c of t plus 13s square. S square can be represented as d square by dt square into c of t. 17s d by dt of c of t. 5 it can be represented as normally only. And then s square d square r by dt square minus 14s minus 14 d r of t by dt and 4 r of t. And this d by dt can be represented as capital D, differential operator. So d by dt can be represented as capital D, differential operator. So that is d cube 13d square minus 17d plus 5 into c, d square minus 14d plus 4 into r. So here the correct answer is, none of the answers are correct and this question is deleted. So option 4, d square minus 14d plus 4, it should be not plus 3, it should be plus 4. Then option 4 is correct. Here none of the options are correct and this question is deleted. Next question. Given electrical network, we need to find out and in the given electrical network, the system matrix obtained from the state space representation if the output is current through the resistor. If this is a current, if this is output current through the resistor and input is V of t, we need to find the state matrix. So in this network consists of L is an inductor, C is a capacitor and R is a resistor. Also given the current through the resistor is output. Current through the resistor is output. So assume the state variables Vc of t and IL of t. So Vc of t is voltage across the capacitor, IL of t is the current through the inductor. These two are the state variables. Next, write state equations. For writing state equations, KCL at node 1. So in the question they have mentioned this is a node 1. Apply KCL at node 1. Sum of incoming currents, that is IL of t is equal to sum of outgoing currents IR of t and IC of t. So IL of t is equal to IR of t plus IC of t. So IR of t is voltage across the resistor by resistance value. So voltage across the resistor is voltage across the capacitor. So this voltage is a node voltage. So Vc of t by R plus voltage across the capacitor can be written as C into dVc by dt. C into dVc by dt. So take dVc by dt, we get minus 1 by RC Vc of t plus 1 by C IL of t. This is one state equation. Next is KVL in loop. To find the next state equation, write KVL in the loop. So that is V of t is equal to L dIL by dt in the complete loop plus Vc of t. Again, if this is a in the homogeneous form, input is treated as 0. From this we will get dIL by dt is equal to minus 1 by L Vc of t. Minus 1 by L Vc of t. These two are the state equations. These two are the state equations. So write the two state equations. We will have Vc dot C, that is minus 1 by Rc plus 1 by C Vc into IL, and IL is equal to minus 1 by L comma 0, and 1 by L is the input. Now we will have the state matrix A is this one, minus 1 by Rc, 1 by C, 1 minus 1 by L comma 0. This is a state matrix. Minus 1 by Rc, 1 by C, minus 1 by L comma minus 1 by L and 0. State matrix is option 1. Next, question number 120. Given transfer function 10s square plus 3s plus 2 divided by s cube plus 3s square plus 2s plus 1. Input matrix. In the question they have asked the input matrix from the state space representation. So we need to arrange this transfer function into a, we need to find the system matrix, input matrix, output matrix from the given transfer function. So here the hint is numerator of the transfer function is C matrix, that is 2 3 1, that is C matrix, output matrix. Numerator of the transfer function will give output matrix. Output matrix is 2 3 1, and the denominator of the transfer function will give A matrix. Consider the coefficients of denominator with opposite sign from lowest power to highest power, that is minus 1, minus 2, minus 3. Consider the coefficients of denominator with opposite sign from lowest power to highest power, minus 1, minus 2 and minus 3, and rest of the elements of this system matrix are same to the elements of identity matrix, but first this starts from second row of identity matrix 0 1 0 0 0 1, and last row of matrix system matrix is the elements of denominator starting from lowest power to highest power with opposite sign, and input matrix is common factor in the numerator. So here common factor in the numerator is 10, that is 0 0 10, and remaining elements are considered as zeros here. The input matrix is 0 0 10. This is B is the input matrix, B is the input matrix, A is the system matrix, and C is the output matrix. Output matrix elements are obtained from the numerator transfer function from lowest power to highest power. System matrix, first two rows are elements of identity matrix, removing the first row, and start from the second row of identity matrix, and third row of system matrix is take the elements from denominator of the transfer function starting from lowest power to highest power, and the common elements in numerator matrix will give the B matrix, that is input matrix. Now from this transfer function the state space representation is like this. In the question they have asked input matrix is 0 0 10, 0 0 10, 0 0 10. Here none of the options are correct, and this question is deleted from the question paper. Let us see one more example for this. So given Transfer function is this one. So from this transfer function, we need to find a state matrix. For state matrix, last row of state matrix is take the denominator of transfer function and starts from lowest power to highest power. Starting from lowest power with negative coefficients minus 9, minus 7, minus 7, minus 5, minus 3 was minus 7. Here third the cube is missing, take it as 0. And for B matrix, take the common elements. Common elements in the numerator. Common element here is 2. So all remaining all elements are 0 and last row is 2. And for C matrix, that is output matrix, takes the coefficients of numerator starting from lowest power to highest power. That is 3. S power 1 is missing. So take it as 0. S square it is 2. S cube is 1 because 2 is already taken as common. That is S is cube plus 2s square plus 3. This is the numerator. This is how to find the system matrix, input matrix and output matrix respectively. And the order of matrix is how to find the order of matrix, the highest power in the denominator. It will give the order of matrix. In the given question, the highest power in the denominator is S cube. The order of matrix system matrix is 3 by 3. So we are getting 3 by 3 system matrix. So none of the options are correct and the correct option is 0, 0, 10. Input matrix B. Hence this question is no correct options, question is deleted.